Okay, yep, ready to go. And now I'm ready to start. Oh yeah, shit, I had this file should not be here. Alright, see ya. Okay. Session 12, I'm starting it at 12:08. I don't even know, it's like the 3rd of August now. Time is just dragging out, like, the 3rd of August. Fantastic. Yeah. I want to get started today. Quick as you like. I will just get to work. And then if I need a break, I might talk a little bit about my streaming schedule, how I'm struggling to wake up on time, and about how Twitch crashed yesterday as well. That was a fun thing that happened. Yeah, so I might have a chat about those eventually, but for the time being, I'm just gonna highly relaxedly continue with what I was doing, which is, going over part 2B here via the blueprint. I was using the blueprint. Bottom right of my Twitch page on desktop, you can find my blueprint. Yeah. It's it's an excerpt from the academic paper that kind of provides a specification for Raft. Raft being what I'm working on at the moment, the second project of distributed systems. Here's the blueprint. Let's just open it up. Just do a quick check that whenever I maximize and minimize my camera. Fuck, I left fuck in the title of the stream. That's unfortunate. I wonder if that violates some sort of terms of service. Let me just know. Do you know what? I'm gonna try to edit that straight off. There's got to be a way. There's got to be somewhere you can click in order to just edit the name of the stream. But where? What I need to do is re-enable when it says to check stream title before you start. That would be good. It would be good if I could re-enable that, because clearly it's not working out so well to just forget about the stream title. That's all sorts of chaos apparently results as a result of that. It's a bit strange. Where the hell? How do I do that? There's got to be just a button somewhere on Streamlabs. Do you know what? I'm gonna Google it. I'm not too bothered about just quickly Googling that, like Streamlabs change title. That's a really simple. Okay, you use the chat because reasons. Pencil icon. This thing. Whoa, what a location for edit stream title. I would never have guessed. Alright. Say goodbye to fuck. Okay. That's fine. That's sorted. Ugh, my eyes. Okay, cool. Well, yeah, without further ado, I'm gonna get on with it. Just a quick note, my plan for today is yeah, the name changed. I'm gonna stick to what I'm doing, the thing that I'm doing. I'm gonna stick to that. That's not useful. Until 2 p.m. today, I'll jump off the stream and watch an episode of House MD. I knew that would happen with the window, but never mind. And then I'll be back at 8 p.m. to push forwards to the end. The end of what? I don't even know. I just, yeah. After the past few days of just being slow and spending too much time summarizing and re-summarizing, which I feel I compulsively do when I stream learning. Instead of doing that, I'm gonna be a bit more focused, hopefully push through. And so I've given myself, work for 4 or 5 hours today. So 2 p.m. and then so from now until 2 p.m. British summer time, and then 8 p.m. to maybe 11. I don't know. A lot of work to be done today. So without further ado, let's push forward. Okay, so Ting Below is what I'm working on. Part B of Project 2, that's 2B. I am, well, I say I'm doing a second pass. That was kind of the idea I had with this. I'm just going to repass it enough times until it makes sense. I've kind of really, I'm focusing in on bits and pieces and trying to slowly but surely analyze them in the sense of breaking them down into small chunks that I can then implement. Have no fear. Analyzed implementation is here. Well, it will be. It'll be easier to implement things if they've been completely broken down. To an extent, a lot of the stuff I was talking about, almost sent a bit of tissue into the fan. Hello. Um, a lot of what I've been talking about, right, is stuff that I think I don't even necessarily need to know in order to implement Raft, because I have very already broken down instructions, which is cool. But I feel like while I'm here, I may as well understand it completely. I prefer doing it that way, because then I come up with my own. God, I come up with my own in implementation that is even in places slightly different from the specification. But then, like, I know the entire intuition behind why it works, and so I can edit it knowing what will happen more or less. And so I just prefer doing things that way. And it's nice to look back over your system and say, like, oh look, this is conceptually what this piece of code is about, and that kind of stuff, without having any black box magic arbitrary stuff. Um, is this hay fever? This must be hay fever. I don't know why else I would be crying this hard. I'm not even talking that fast. Sometimes if I get overexcited, I also cry, but I think this is hay fever. I might have to blow my nose a bit, but yeah, it's okay. So yeah, basically that's my philosophy. So I'm happy to take it slowly as I'm comfortable with it. So it's been pretty slow so far. Um, Slower still because of the stream. I can definitely work faster if I'm not streaming. But just being able to sort of verbally break everything down is good, and I like doing it that way. I think it's good. And that's part of what the stream is about. It's good practice for explaining stuff, interviews or whatever. Just being able to say what you're thinking is nice. Okay. Yeah, funnily enough, House yesterday had an episode of these are some reruns. I think House is over, but it had this episode that was just somebody who lost their inhibitions in the prefrontal cortex and just said everything that they thought and ruined all their relationships, everything that crossed their mind. Um, and everything they said was true to them, which it was just no filter speaking. Which kind of what I'm pushing for here, but yeah, that was over the. It was going too far, because then you can't maintain relations with people if you are like that, because people will always bother you, but you shouldn't always be calling them out on that, which is fair enough. Okay, first a nose blow, and then I'll start working. Yep. Oh god, I'm thirsty and my throat is gonna get blocked again, but such is life. No use complaining about all that stuff. Sorry, let me just... Camera stand is a bit rocky. Yep, okay. Yeah, so that's what I'm doing. I'm just going to push forward with that. So the bit that I was working on, so I'm sketching project 2 part B, before implementing it and then debugging it, which is going to be a riot. Before I do all that, I'm sketching it, and so requests, I'm breaking down everything that I haven't done yet, which is mostly but not entirely, this section, receiver implementation of append entries RPC, and also this, which is also mostly about append entries, as you can see, which is sender implementation, loosely speaking. Sender implementation is here, receiver implementation is here. They're in different categories because of reasons. It's not very well written blueprint, to be honest. I could have written this better, but whatever. So receiver implementation is what we're starting with. And this is where it's all written down in this section, append entries receiver. Append entries is one of the two RPCs, which is instances of the protocol by which different servers, computers communicate with each other. That's the append entries. That's what this is. And append entries is all about one server sending to the other. The leader is the only one that sends append entries, as in they only get sent if something thinks it's the leader of all of the others. And what it is doing is it's sending heartbeats which tell the followers it's still alive. And some of these heartbeats include data, which is the stuff that Raft is actually transmitting, transferring and synchronizing, getting consensus on or whatever. Yeah, just it's still not completely clear what Raft does. I'm at pains to admit that to myself, but yeah, it's basically all about agreeing on an order of operations for a log, basically. The log stores a bunch of operations, or just data. I just call it data. They call them commands because it's supposed to be commands for like a state machine. But I'm not. It's just, yeah, a data log that has to be in order, and that gets, consensus with, between the leader. If the leader breaks, someone else picks it up. So the leader and the followers all agreeing that stuff, and that's the data that's getting transferred. It's a bit of a nebulous concept, not gonna lie. But we'll see why exactly it's useful when it comes to Project 3, which is unfortunate that we have to do Project 2 slightly blindly in that sense, but I think it'll all be alright on the night. So, append entries receiver, okay. This is what I'm working on at the moment. So, success is something I covered in the previous stream. Well, I say covered. I'm still not sure why success is defined this way, but there it is. So success, which I've already done, is about when does the receiver of an append entry is from the leader, but the thing that receives it, which is a follower usually, or not, but if things are working smoothly, if Raft is working smoothly, then it's going to be a follower receiving append entries. So success is the thing that it replies to the sender, which is the leader. And that is TS React. Well, TS stands for term sync. It's about synchronizing terms and making sure everyone is up to date. And term is used as a way of determining who broke down and is now out of date. And so React is all about, is the sender's term at least the receiver's term? That's to say, the sender dominates the receiver. So I came up with the domination order relation between servers. If someone's term is greater than or equal to the other's term, then it dominates that server. Which is cool. The point is, domination is basically equivalent to should the receiver be listening to the sender, because if the sender does not dominate, then it's out of date, strictly, compared to the leader, the receiver, sorry. And if that happens, then the receiver should just drop the request. And so in that case, TS react is false. And because that's in conjunction with this, that means that success is also false. So TS react is a prerequisite for any RPC response being given, any RPC being heeded, append entries or request votes is the other RPC in the election phase, in the election cycle, I should say. All that stuff is, both of them are subject to the same rule, that the receiver only reacts if the sender dominates the receiver, and that's why TS react is defined. So that is a prerequisite of, okay, I should actually pay attention to this request, but then the actual success of the request depends on this, which is to do with append entries itself rather than a generic thing for both the RPCs. And I couldn't tell you why it's defined this way. We'll find out later. It's a bit strange. It's about the log containing an entry that matches prevlog index and prevlog term, which are sent by the sender, and what those mean is the sender's entry before payload. The payload being the things that the sender is currently sending. So prevlog index and prevlog term are the sender's entry before that index and term. Well, this might not strictly be true the way I've written it. It might just be the last thing in the sender's log. I'm not sure. So I'm just, I'm talking about, a lot of the time I'm just saying my theories for what stuff is and leaving possible mistakes in, but they'll all get fixed eventually. Hi, welcome to the stream. I'm working on Raft, the MIT project 2, out of 4. There are useful links underneath my stream if you're on desktop to what I'm actually doing. But now I'm on a really gritty part where I'm just trying to sketch out, get a hold of all of the details for part B of Raft before I get to actually coding it, and that's all about how data is handled, how things are sent. So append entries, the logs, the synchronizations, the consensus, all the core stuff. Because part A was about the leadership elections and the heartbeats, which is a kind of empty version of what we're doing now. No worries. What's my summary? I'll start from the top. So I'm doing the MIT Distributed Systems course. I'm doing it practical oriented, right? So I'm just starting with the practicals and seeing how far I get. So I'm not actually a computer scientist. I don't have any background on this. I'm just learning by trying to do the projects, following instructions and all that. So I'm on project 2 out of 4, which is on Raft, which is a consensus algorithm. I couldn't tell you exactly what that means yet because I haven't seen a use of Raft in the real world or in a project or anything. I think project 3 is a use of Raft, but now I'm just doing Raft itself. Bottom right of my stream page, there is an illustration of Raft, which is a kind of quick, if you don't know anything about Raft, it's kind of helpful to find out how it works. It's a kind of democracy of a distributed system, a democracy type algorithm. And so I'm on part B of the actual coursework, which is about the actual transmitting of data and consensus and logs and all this stuff. Whereas part A was about the leadership election and the heartbeats. And it will take a long time to explain all of that, but the illustration is there if you're interested. So that's what I'm doing now, is trying to sketch all of that stuff. So this is the blueprint, which is a kind of specification that's in the academic paper, link in the same place, bottom right of my stream page. And so I'm just trying to break down the individual bits and, I don't know, get my head around them. So I hope that that's vaguely clear what I'm doing. Yeah, I'll get to it. I wanna kick out quite a bit of work today. Streaming until 2 p.m. British summer time, and then fly. And then I'll start again at 8 p.m. today. So I'll do quite a few hours, putting in the hours. Um, Fucking fan almost slipped off. Stop, please. All good. Delicate. Um, Yep, so the bit I'm focusing on now is append entries, which is the RPC, the communication from between two servers, that is the leader telling another server that it has new data that it wants the other servers to also write down, and also the leader staying in touch with all the other servers, because if append entry stops and a re-election is triggered, that's the heartbeat, but that's something I've already implemented, so I'm only interested in the data stuff. So these four things are, well, so step one here corresponds to these first two steps here, and then the other three, 2, 3, and 4 are respectively 3, 4, and 5 here, which I'm gonna need to try to get an understanding of. That's what I'm doing now, because 1 and 2 I've already done. 1 and 2 are all about this arbitrary definition of when append entries is successful, which I still don't strictly understand. The receiver has an entry matching the previous entry of the sender is effectively what this is saying. And that's written down here. And I was just saying that I'm not sure if this is defined correctly, but we'll see how it goes. Payload being the new entries that the sender is sending over. So this is the previous entry. And if the previous entry matches, that's supposed to be a success on the send of the new entries, which I find a bit strange. But that's the kind of thing that we're going to try to get our heads around just by getting through all the other bits and pieces and seeing if we can put together the jigsaw effectively. TS React, I won't mention what I mean by that again. It's just it's basically something I've already done, and it's all about should the receiver even respond to the sender. The answer is no if the sender is out of date, because the network broke down or something. And in that case, TS React would be false based on how I've already implemented things. So that should be all good. Just check that the stream is still working, because I'm streaming on a single monitor. Seems to be more or less fine. Camera and microphone, all good. Actually, it looks a bit out of focus, so I am just going to see if I can refocus my camera quickly. It shouldn't take a minute. Yeah, it's gone a bit out of focus. This is a manually focused camera, which I think is useful, actually. Better to do that than an autofocused one that doesn't work very well. And autofocus, I find, often doesn't work very well if it just keeps refocusing arbitrarily. But this is it's a bit. It just stays. If I don't move too much, it just remains still. Okay. Yeah, without further ado, okay, let's try to get through these three bits and pieces, and then we'll try to look at some of the other stuff that, needs to be done. Okay. Intuition so the bit that I was working on before I stopped is number 5, actually. So the last one, number 5 here, number 4 on the in my scrap notes. This is all about commit index. So I came up with a new order relation called leading. So I'm defining my own words, really, just to make things a bit easier linguistically. So when I'm talking through everything, it's a bit easier. So we have two order relations. I'll just write them down here in a quick bit of scrap notes so that we can be clear on what they are. So order relations between servers. So an order relation in maths is like less than or equal to. and that's an order relation between numbers. And so I've defined a couple of order relations between servers, namely, so servers A and B, let's call them A and B. A dominates B if, so this is my first definition, A dominates B if the term of A is greater than or equal to, I don't have my custom keyboard layout where I could just type greater than or equal to. I need to install that on this new laptop. I would, yeah, all the gr equals and then the greater than sign, it would just type in a greater than or equal to because of custom keyboard layout, which is cool. Yep, so this is the first relation, and this is all about who should be listened to in an RPC. You know, if someone's out of date, you drop their request, basically. And the other one is about leading, and leading is about who is more up to date on the data. So this is about commit index, right? And so commit index is defined here at the top. It is what I think, by I mean the server whose commit index it is, what I think is the highest committed entry. And loosely speaking, all data goes through a cycle of getting written, then getting committed, which only happens when it's acknowledged, i.e. written, and then reply, yes, I wrote this down, from a majority of servers in the Raft cluster. And finally applies, which is about the final service that uses Raft getting the information that everything has been synchronized and is in order. So that's commits. That's what commits is about. And so commit index is what I think is the highest committed entry. And that starts at 0, which signifies no entry because the first entry is at 1. It's 1 indexed. And then it just increases monotonically, so it should never decrease is what that means. So it's an integer, a natural number, natural 0 number. So A can dominate B while B dominates A. Yeah, that's yeah, because I guess because I'm I don't know. I guess it comes from my maths background slightly that I tend to use the simpler words, to mean greater than or equal to. It's like that's the main order relation, and then we can also say strictly. So I would say like strictly dominates if I meant strictly greater than. But yeah, you can have A dominates B and B dominates A. It's not worth worrying about. But yeah, linguistically that's a bit weird. But yeah, that would just mean they are equal, like you probably figured out. But that's just, I think it's useful. If you're learning anything, it's useful to define your own stuff, particularly if it keeps your thoughts in order. It's not too complicated to figure out what you meant when you defined it. But I think these two definitions are quite clean, so I'll stick with them. I can always just scroll to the bottom to remind myself or anyone else what they are. So how does commit index work then? So commit index is the thing that's about leading, in the sense that's how what I said is comparing commit indices. And so what I wrote down here, what it says is if leader commit is greater than commit index, which is this paper's really unhelpful way of saying if leader commits, namely the leader's commit index, and what that means is actually the sender's commit index, because that's what is. Arguments is the stuff that is sent by the RPC, through the RPC, sorry. So leader commit is the sender's commit index, is strictly greater than commit index, which I have to scroll up here, is my own commit index. So sender's one is greater than mine, and I am the receiver, so that sender is greater than receiver, i.e. sender strictly leads receiver. That's what I've written down here. Then we set commit index, my own one, because I can't set the other person's commit index because I'm a different computer to them. Set commit index to the minimum of the sender's commit index and the index of the last new entry. I don't know why. It's a bit it's going to get a bit confusing until we get it all of it. This is you have to kind of, I think, have everything in your head at the same time, even just for a little bit, in order to figure out why things are defined as they are. That's the thing that sort of bothers me about this. Is why it's a bit difficult, but yeah. Challenges are fine. I don't mind the challenge. So yeah. Set commit index to the minute. I actually have a cleaner way of writing this, although I'm not going to rewrite it. But I think the way that this should be thought of, this bit, set commit index to the leader's commit index, basically. So I'm updating to the leader's commit index, unless the index of the last new entry, which it's not clear what that means, but I think it's the last entry that was sent in that particular message from the sender to the receiver. If the index of that is smaller than the leader's commit index, then we set it to that. But I think if things are working correctly, so that's a good way of thinking about what the intuition is how should things work, provided there are no problems, provided that none of the servers break down, everything is always up to date. Answer, I think commit index should just be replicated, as in I should set the commit index to be the leader's one, and the leader increments commit index. Like it, followers increment commit index only by doing this, so i.e. they are synchronizing with the leader. So receiver of an append entries is going to be a follower, provided things are working smoothly. Okay, but the leader itself also increments commit index in a different way, which is it literally just plus ones it under a certain circumstance. And I think, to be honest, I will look at that now in order to try to get a complete picture of how commit index is updated. I'll have a look at what the leader does. So I know what the follower does to keep commit index up to date. I'll take a look at what the leader does. But basically the intuition here, I think, is that if things are working fine, then the follower is just copying the leader's commit index, as in it's keeping up to date with the leader by doing that and following the leader's lead. But we also have this technical thing here, which I'm not sure about yet. But that's my current interpretation going forward. So let's take a look then. Let's take a look at how commit index is updated by the leader, and so that's going to be written here. Do we see anything about commit index? Scrolling. This is the only bullet point that mentions it. Yep. Well, you can already see this is quite complicated. Dearie me. So if there exists an integer that is, if there exists an integer greater than commit index, the current one, such that the majority of this is okay. This bit I can't highlight on Edge because why the hell am I using Edge? Edge is shit. Control X, close. But to be honest, Firefox isn't that much better. Its PDF viewer is a bit trash. I really ought to install an actual PDF viewer, I think. But yeah. This also, how do I highlight in Firefox PDF viewer? I also, oh my god. I can't, can I? I can't highlight at all because this is a picture, figure 2, I think. Never mind. Okay. So I'll just try to point it out as clearly as I can. There exists a natural number bigger than commit index strictly, such that this bit, a majority of match index greater than or equal to n. Match index is the leader's what the leader thinks is the commit index of the followers, I think. This is where the academic paper being poorly written is causing problems. I think for each server, index of the highest log entry known to be replicated on server, is that the index, is that supposed to be the commit index of the other server? Well, if you read the definition of commit index, it's pretty similar, but it says instead of replicated, it says committed. But I think those are equivalent because you only commit when things have been replicated to a majority. So my working assumption is that match index is tracking everyone else's commit index. So the leader tracks everyone else's commit index via match index. I think that's what that means. Sus Lord. And so when it says a majority is greater than or equal to n, that means that's not true. That's not true. What I just said is not true. I think this is not. When it says replicated, oh, okay. No. I think replicated is about writing rather than committing. So just to get another overview. So this this data cycle thing that I've written down here, I pulled this out of the illustration of Raft. This is why I think the illustration is useful, particularly on the data, how data is dealt with. The illustration kind of provides a number of pointers. And so this list of things that happens, when the Raft thing, when the whole of Raft, the algorithm somewhere receives new data, the leader handles it. It writes it and sends it to followers. The followers then also just write it and acknowledge they've received it. Then the leader commits when the majority have acknowledged, and then the followers commit according to the leader. So this step is the one that we have been talking about, is to do with the followers updating their own commit indices, depending on the leader. That's kind of what this is, I think. This is the bit that I'm looking at now, which is when does the leader commit. So this is about the majority acknowledging, and that means the majority has written rather than committed. So we're looking at writes, and writes happen immediately. Whenever the leader sends any new information, it's written. My throat's a bit screwy, this always happens. I just get phlegm or whatever. Hopefully I'll be okay, but particularly with these early morning streams, it's past noon. I started at 12 p.m, but I still call this an early morning stream. If you're going to bed at 3 a.m, then yeah, that's how it works. But yeah, they just leave me in slightly worse health, like, I don't know, phlegm and fucking. Okay, I should be okay. It's just the fact that I'm speaking a lot that just triggers my throat slightly. I'll leave it at that. Speaking triggers my throat. It's basically what's going on here. Okay, so taking it back to this shit. I shouldn't alt tab like that because then I could accidentally screw up my camera. Yeah, camera's fine. So this bit here. If there exists an n, okay, yeah, so this thing, a majority of match index greater than or equal to n, that means that match index is about what have the followers written rather than committed. And so if the majority is greater than or equal to n, that means that we think that a majority has written our latest entry, which is to say that we should then commit that entry by incrementing commit index to cover that entry. That's what we mean by commit. It's not like we copy to another log when we commit. Instead, we have an index that tracks how far up the log has been committed. And that's what commit index is. So a commit index is tracking commits by going up the log. Match index is what I think is, there's no such thing as write index about, the latest written thing, but match index is kind of like that, except for all the other servers, and the way it's tracked is by the leader getting responses on when it sends data to the followers that it's tracking. We have another technical condition here, which is that the term on the last entry has to match the current term. That's to do with making sure that the log is actually working, is actually up to date correctly, because if every log entry has a term assigned to it, and that term is the term that the leader received the log entry, and term is a variable that's incremented whenever a new leader is elected. Slash, strictly speaking, term is incremented whenever an election is called for a new leader. And so this tends to be, just generally speaking, this line here, log term equals current term, is just a check that we are on the same term. There hasn't been a re-election, because if there has, the thing that's newer, whatever it's saying the term is of the entry that it's trying to write down, that dominates. And so if this fails, then commit doesn't happen. That's kind of just very, very intuitively, yeah, that's what each of these bits means. But like it's really hard to know technically if this works correctly, to break it down so it technically makes sense. But if we keep going, I think we will get there. So I'm going to push forward. It's a very complicated algorithm. I'm under no illusions at all. So okay, hay fever. I think this is hay fever. I don't know how many streamers on Twitch wipe their eyes constantly, but it is a bit of a thing with me. Because I have this window open, because I'm trying to keep the laptop as cool as possible, and myself as cool as possible. Because it is now... How is it only 21 degrees? It's more than that, surely. Yeah, it's 28 degrees. This is what I mean, it's ridiculous. It's going to peak at 30, and I have 5 days in a row of this. Oh dear. Yeah, so no wonder my health is not really succeeding. I'm gonna quickly blow my nose, so I'll just mute. I mute the microphone whenever I blow my nose. That camera nudging, I always do that because I want my face to be in the middle of the camera, but it just moves because obviously I move about. And my camera stand is literally just on my bed as well, so it's susceptible to moving if I move or anything happens. I don't know. It's like I'm pretty centered now. Wait, just a little nudge. Yeah, now that's perfect. I think. Cool. Thank. Sorry for wasting time doing that. But yeah, that's all good. So what it says about the leader here, one thing I don't know strictly is, okay, so I know that this bit is basically covering how the leader handles commit index. That's something I've said. So we've done how the follower handles it, but the thing about the follower is it receives append entries, and so that's a good time for it to do this step where it handles its own commit index. So commit index sync is basically what this step is. Why wouldn't I just name it sync my commit index? Or indeed commit index sync. The way that the leader keeps track of commit index is different, and we've been through that. But the thing is, this is conveniently done whenever the append entries RPC is received. I don't know when I should be doing this. When is a good time to synchronize the leader's commit index? Um, okay, so strictly the leader, all that the leader is doing is running the heartbeat code that sends data out periodically. So we already have a periodic loop, a periodic rather than a periodic. We have a periodic loop already. That's there. We could use that, I guess. The leader is always just doing a whole lot of stuff. So command received from client, that, for example, is triggered when by a different function. We already have a function that's called by the client in order to send the command through. It's called start, I think. So that is a convenient time to do this step. This step is just periodic, so we already have those kind of, we know when they're supposed to happen, but when do these two happen? That's what I'm thinking. So let's have a quick look at this one, which I haven't looked at yet. Basically, it checks followers. It checks followers. It checks what it should be sending to the followers. So next index and last log index are all about they're all about tracking the follower's log. How up to date is the follower on all the data? And if this happens, send more data and retry if it doesn't work. And so it will spam append entries. I don't think this happens on the heartbeat. I think this happens off the heartbeat. I think because append entries is already being sent via heartbeat. And so the design decision to an extent is, do I send extra append entries if I want to send data? Or do I put the data into the heartbeats? And in this case, I think it is saying, heavily implying, that it should be sending extra RPCs in this situation and, retry, meaning it does it independently of the heartbeats. Because the heartbeat should really be going out to everyone at the same time. It would be sensible to keep the heartbeat homogeneous between all of the receivers. So all the receivers receive the same data in the heartbeat. And so the heartbeat is just about keeping them up to date with the latest data. But it is definitely possible that one of the followers, it crashed and then came back to life. And so it needs more than just the latest data to keep it up to date. In that case, we send extraneous append entries, RPCs. This shit here, send extra append entries, RPCs, in order for that to happen, and then independently of the heartbeat, we can continually, retry. Basically, the retry step is, it says decrement next index. So the retry step is all about, oh, you don't have enough data, I'm going to add in the next previous bit of data and see if that's good enough for you. Something along those lines. And then it goes backwards until it captures all the data, sends all of that in one block, and then it can read from the heartbeats all the latest data, if you see what I mean. So all the stuff that I've just said is a theory. I'm not sure that's actually how it works. Part of why I'm having to do all this stuff is that I haven't read the lecture notes at all. I don't know the details on anything, but I'm trying to figure them out from this. And I think it's not necessarily the right way of doing it, but it makes it more fun. That's why I'm using that kind of approach. Yeah. That's the thing about Raft. It's just ridiculous. Somebody already came through and said, "Oh, this was a trip." They called it a trip and said, like, "Yeah, I had to sketch this on a diagram to make sense of it repeatedly." I'm going diagram free because it's a bit easier to not stream diagrams, but I don't know if a diagram would help me for the time being. It's just, yeah, an absolute chaos if you read the blueprint. I mean, you can imagine how many hours it took me the very first time I read the blueprint just to get some hold of what was going on. So quite happily, the bits that I've already implemented, I don't think they're as complicated as this, but it's nice to have been able to break off a bit of it and get it independently implemented in a way that passes all the tests. And not only does it pass all the tests, but it's a system that's well, it's a system that works in a consistent way that I can predict exactly how it's going to work because I coded it quite slowly and carefully. So it's nice having that to fall back on, but now I have to try to put all this extra stuff into it. Yeah. Just as a quick note, if you're, I have a file here. This is on my GitHub. There's a GitHub link. You can find it all there in the scrap folder. The code so far, which is well, this is a vaguely diagrammatic thing that I did here that kind of explains all the cycles that I've implemented so far. And this is already quite a lot of shit, as you can see, but that's the stuff that is already in place and that I'm adding to. And I managed to summarize the entire code in this small document. And I think all of the implementation details are captured by this, which has made it a really useful exercise to summarize it this way, just so I really know what my code does so that I can predict if something's gone wrong from what I implement next, where the problem is, if you see what I mean. It's madness. But yeah, that's just on my GitHub. For the time being, I've moved on. I'm pushing through into the new stuff. Hey, what was... Okay, well, what I just said, my theory about this and this, it could get a bit sketchy. I don't know. So my first instinct was that these two steps here should be being handled on every heartbeat, but not as part of every heartbeat. What I mean by that is because the heartbeat is a thing that regularly ticks. So the leader is always sending out append entries. And so all of the code so far that pertains to the leader, the only thing that the leader does so far in my code is to run this cycle of heartbeats. So it's a tail recursive with delay, kind of like, in JavaScript I have a function that like does something and then calls itself with a timeout. That's the idea of what I mean by this loop that is tail recursive with timeout. That the leader amounts to literally just that. When something is leader, all it is doing is running that loop, and that loop sends out an append entries every loop instance. And so that means I have a regular period that I can use in order to do these two things, which is cool, but I need to watch out that you see how it says here I can't highlight, it's so annoying. I have this cycle of append entries that I have to keep sending in order to keep a follower that's out of date up to sync. So I was talking about that just now. I can't just do that every heartbeat. So my thought was, do this check every heartbeat, but then I can't send the append entries RPC out every heartbeat because the append entries RPC, like this loop here, just keeps calling itself until it's done, but it might be too slow that the next heartbeat happens while this is still going, and then it would start again because these variables probably wouldn't be updated in time because it's not, it says update next index if it succeeds, but if it doesn't, it will just keep hitting that, and so it'll keep running this code, and it will keep running like chains of loops, if you see what I mean. Which is why I can't just naively do that. I have to be a bit more careful, and so maybe I do have to synchronize append entries to heartbeats. Maybe I cannot get away with just sending out a chain of append entries. Potentially I can if I just put in a variable that locks the thing and therefore says, oh, this is already happening, don't do it again. A quick lock variable is a reasonable way of maybe getting around that. So I have these two choices effectively, and I'm not entirely sure which one I'll go for, but we'll see how it goes. Um, just before I check the chat, this last one here is not affected by this problem because it doesn't send out append entries. It immediately finishes. So I can actually do this on every heartbeat. It's just a quick update, check and update, and it's pretty reasonable to do that on each heartbeat. Maybe even more than once per heartbeat because it's just so fast. But we'll see that when we actually get there. For the time being, it's just I'm just trying to vaguely get an idea of what happens approximately when, rather than the actual implementation detail. Yeah, Stack Overflow is a reasonable place to check this stuff. I don't know how many people would have actually gone through the process of implementing Rafts. I guess people who did the MIT course will have been through this, and so maybe someone might have commented if it didn't, then they'd get deleted for like cheating or something. But um, yeah, that's fair enough. It's a good shout that I will be able to check Stack Overflow. I'm not gonna do that now because I'm happy to leave it unsolved because I'm just trying to get a vague idea of when things should happen, and so I'm predicting future things that I'm going to be grappling with rather than, because now what I'm going to do is just move on, make a note, say, to kind of describe my ambiguity, and then just move on and try to cover all of the other components because there's still like lots. There's still another 5 or so. Hopefully I can get those kind of summarized by 2 p.m. That's my aim. I'm watching House at 2 p.m. It's going to be fun. Well, a nice break at any rate from all this shit. So that's why I'm happy to just kind of leave it. But yeah, effectively these 2 things here. So these 4 bullet points. This is describing the loop that the leader is doing, and I've already implemented this. So this is describing what the leader is doing, effectively, in the background. This is describing what happens when a particular function is called, namely the client calls a start command function, and that then runs this, and so this depends on that happening. And then these 2 things I was saying, I'm not sure when they happen. They're kind of independently. These should be always being kept up to sync, up to speed. And so different ways of implementing that, but that's enough worrying about different ways of implementing that. We can just what I'm going to do is just make just another paragraph here that is leader well, what's a nice snappy way of like writing a heading, a subheading, meaning like things that the leader should be doing all the time, sort of. Not in the implementation, the leader should not be like running an infinite loop of this, because the way that Go works, that will just block something. It's really dangerous to do that. So you have to be a bit more subtle with how you design your program. You can't just you can't spin up a thread and then just get it to infinitely do this. I guess you can if you put in a timeout or spin up a new thread for each check, but then that's quite computationally expensive. And this is why I was thinking, maybe it makes more sense to synchronize it with the heartbeats. It's less thread switching and all that kind of stuff. All right, so that's enough rambling about implementation. What do I want to put here? Like, leader. Just let's use some stupid language that I'm not happy with because it's the first thing that popped into my head. Things the leader keeps on top of. And I'm just gonna, I guess, put in these 2 things. So I haven't actually thought about this one yet, but this one we've had a bit of a think about. I'll put that in. So I'm gonna preserve the order of the blueprint, even if I don't preserve the numbering. This doesn't even have numbering, but this does, but this doesn't. Do you know? I think what that means is that I should actually implement this in this exact order, as in the code should be doing these 5 things in this order. I think that's what it means that they have numbers here. Yeah. All these questions, all these decisions. This is why I kind of enjoy this project. It's difficult because you have to call the shots yourself to an extent. It would be easier if I did the lecture notes, but then I wouldn't have that freedom and the learning of, oh, I did this wrong, so I have to change it. And what do I change it to? That kind of thing. This is why I think with a lot of things in life, it's just cool to learn them that way. To learn them kind of unaided, where you're allowed to make mistakes and try again. Um, and just as a general principle, I do learn things a lot that way. It's basically the epitome of the philosophy of like. Um, so when I start saying things like that, I always want to check that my stream is still going. Yeah, it's basically the epitome of the philosophy of if you copy answers for a problem, then you don't learn anything. So this is what I'm doing is I've basically kind of added an additional challenge where I'm not reading lecture notes in order to go to the other extreme of that, where I learn more from my failures, basically. Um, but that's not the reason that I'm not reading the lecture notes. The reason I'm doing it this way is because I like doing things practically oriented, and I just don't like explicitly studying. Um, so I'm trying to study as little as possible. That's the reason that I've actually done it this way. But yeah. Okay, so let's cover these 2 points. So first of all, this one. Let me just rewrite it. God, my eyes have started to struggle a bit. All right, so what this is commit index. I'm not gonna call it sync, but it's I don't know. I'm giving things slightly arbitrary names. So commit index sync is the thing that the follower does, and commit index track is the thing that the leader does. That's whatever. But it's not. The titles are just kind of a mental notes. Really, what I care about is the comment. So this stuff here. That's what I really care about. Shall I just again? Sorry. Just before I answer the comments, what I will do is write this out. I'll just type it out, so it'll take about a minute. And then I'll just briefly comment on it. So this is if exists n greater than commit index, such that majority match index greater than or equal to n, and log n dot term equals current term. Current term is my term. I'm just going to put my term because I find it easier to understand what that means. Then set commit index to n. Let me break that down. Actually, yeah, I'm just going to write it this way. All right, let's have a quick look at the note. I don't like pushing my face to a book either. Would rather learn by doing. Yeah, that's it. 100%. Yeah, I mean, in my maths degree, because I did a lot of pure maths, there was a time when I was happy to just work through theory bit by bit, build up a mental model and all that. But the reason I'm not happy to do that with computer science is basically I don't think computer science is as nice. It's not as gratifying just for its own sake. The theory isn't as pretty somehow. Like with the pure maths, I was happy to just build it up because I felt like I was building a castle just purely in my head. But with computer science, I really only want to know the things that are actually practically useful for the algorithm or whatever I'm working on. And so, yeah, that's another, because I have been there, that I have enjoyed studying from a book. Um, that is something I've done, but I did get bored of maths. I definitely got hours. I was not gonna. The more specialized it got, the less I cared. So I was kind of this third year undergraduate course on functional analysis that I kind of peaked there, and I was like, okay, that's enough. So I'm doing Komsky now. Yeah, so this is it, right? There is one thing I should point out here that I haven't mentioned yet. You see how it says n is great if there exists an n greater than commit index. This is implying that we care about the biggest possible n, so we're not just incrementing n. Instead, we're trying to find the biggest n for which this works. In fact, I would even just describe it as max of n where it exists. That would be the mathsy way of putting it. Maximum n if existent, because you can see how it works here. It's implied from the rest of it. It says, the bigger this, if you think about it, the bigger this n is, then we're trying to find kind of the biggest n that match index. The majority of match index is still greater than or equal to it. So we're kind of finding the minimum. Kind of like the minimum that means that the majority of match indices is above it, which you can think of as the maximum that satisfies this. Yeah, it's a bit. This is something because I did a lot of analysis in maths. It's something I'm familiar with, but it can get a bit confusing to describe things because you can either describe it as the minimum of the match indices that are like that makes it work as a majority, or the maximum of the. Nah, never mind. Sorry, I'm just going to confuse myself as well if I start talking like that. But basically, okay, the match indices are just a bunch of numbers. We're trying to pull up n, to find one that is still the biggest possible one that satisfies that a majority of match indices are still greater than or equal to it. And provided it also satisfies this, then we can set commit index to n. And we are, I think, intuitively wanting to make commit index as big as possible. Because then we have to update it one less time in the future. Not strictly one less time, but you take my point. It's like, it's kind of, we want it to be as up to date as we can, and so that's why we're kind of looking for a maximum. Because another thing, this is a monotone property in the sense that if n satisfies it, n minus 1 will satisfy it as well. Because n minus 1 is less than or equal to this, so that which is less than or equal to match index majority. And if log n term is synced, will n minus 1 work? Not necessarily, but I don't know actually. Possibly not. But then again, what commit index is saying is I have committed everything up to this point, and so commit index being n minus 1 should be like strictly weaker. But I can't see that means that log at n minus 1 satisfies this property. That's not implied just from the definition. So I don't know if this is just an extra check or something. Certainly. So again, I'm trying to draw a distinction between things that are intuitively the reason we're doing something and things that we're adding on as an extra check to make sure the algorithm's working correctly. And so when it comes to tracking commit index, this is the reason we're doing it, and this is a check to make sure that things are working smoothly. Because this is unnecessary, assuming that none of the servers break down at any point. And the same was true when we did this follower commit index. That the thing we set it to should be the leader's commit index. And I think that this is just there in case something goes wrong. Again, that's just a theory. We'll see how it goes. Hopefully I can keep all this in my head long enough to resolve it. Because if I forget and I've just written something down that's wrong, that would be bad. But this is I'm trying my best here, to be honest. Okay, cool. So That's commit index. Okay, so this is this is how commit index works. This is what the leader is doing to it, and this is what the follower is doing to it. So the follower does it whenever it receives append entries, and the leader does it, I don't know when, but we'll figure that out later. It should be doing it, theoretically speaking, it should be doing it always, all the time. It's something the leader's trying to keep on top of as best as it can. Theoretically. Practically, that's obviously not good enough, but we'll get to that later. Okay, so let's have a look at this. The other bit of the leader that I haven't covered yet. This is a bit more confusing, I think, than commit. Commit is it though? I don't know. Okay, so this bullet point here and these two here, 3 and 4, the ones we haven't done yet. These are about keeping logs up to date without committing. So commit is something we've spoken about already. Commit is, I think, intuitively supposed to be, we have consensus, we have agreement, this is not possibly going to change. So commit should be like, everything that we have so far is definitely done. Oh, another piece of evidence that that is in fact true is there's another line, there's another sentence somewhere. Let me see if I can find it. That kind of heavily implies that that's how it should work. Here. If commit index is greater than last applied, increment last applied and send the log entry to the state machine. So this is all about Raft finishing by saying it's done this entry. So whatever service is using Raft, which I don't know if state machine is being used to mean a similar thing here, but I think, but I don't know. I can't guarantee everything that I'm saying, but you take my point. I'm trying my best. What this is all about, applying, is about transmitting the information out of Raft and onto the service that's using Raft. That's what apply means, and we have functions that we call, I think, that do something outside of Raft, so they're not internal to Raft, that represent applying. I can actually verify what I've just said because I have this document on the interface of Raft. And the interface of Raft is all about how Raft communicates with the outside world. So the internals are most of what I'm working on. But the interface, you can see already here, there are certain functions. So start is the function that whatever inputs into Raft puts a command into start, and then Raft gets to work on it. And that's how Raft gets data. How does Raft send data out? It sends it into the apply channel. Channel to receive apply messages for each newly committed log entry. That's already there in the code, so the project as MIT sent it already had an apply channel in it. Every server, no matter if it's leader or follower, is applying entries, and what that means is it's sending them to this channel, which is the exit channel for Raft. The data goes out in that channel, and then whatever the service is, I guess, I don't know, reads from whichever channel it can, and all the channels should be 100% consistent with each other, the data they receive, and that's as a result of the Raft committing and getting consensus and all that. But to not digress too far, what I mean is that apply is the final step. We're done with this piece of data. We can, Raft is finished with it, and the exit, like the service that uses it, can then pick it up. And as you can see from the blueprint, sorry, just whenever I minimize and maximize, I just check my camera's still working. Whenever commit index exceeds last applied gets incremented and apply happens, so it gets sent into the exit channel. Therefore, commit index is Bible. It just gets transmitted to last applied all the time. But commit index is basically like, this is it, this is finished. Excuse me. And so that's what commit is. Okay, so yeah, that's can't remember why I digressed to talking about that, but that's what we've just been working on. The two bullet points that handle how commit index is updated, so how committing works. But what we're now going to look at is how writing works. So instead of commit, write. So in my data phase breakdown, I spoke about applied just now and commit, and this is write. And this is basically how write works. So this is what we should be bearing in mind when we read the next bits. The leader writes as soon as it receives something. Okay, this bit is handled by, I think, the first bullet point here. Well, the first one that I haven't done, so the second one, this one. If command received from client, append entry to my log, leader. So that's what the leader is doing. And okay, the response after it's been applied is a different thing entirely, but we'll think about that later. But basically, that's just this bit. So the bit that we're now looking at is this. Sends it to followers. That's how append entries begins in the first place. And the followers write it down into their own logs and acknowledge receipt, which is kind of what success is about in append entries. With this arbitrary definition that I don't see how it matches yet. But I don't know. We'll find out soon. I don't I don't know how this definition of success matches what we think success should be according to this breakdown here. So Raft is, I kind of like this project because it's all about reconciling lots of different clues, lots of different bits of information from various sources. Sure, that's cool. Even though, I appreciate it's taking quite a long time. Followers write and acknowledge receipt. Yeah, that's what we just said. So these are the things we're bearing in mind. That writing, unlike committing, doesn't require a majority or anything. It's all about sending the data out as quickly and as best you can. So, with that in mind, okay, one more thing. You see the state variables. It's been defined independently of everything. So I have my state variable definitions. I have my data cycle, write, commit, apply framework. And I also have all of these bits and pieces of implementation detail. These are all independent of each other, and I have to reconcile them. So when it comes to the state variables, based on what we were talking about, we think that match index is about the leader paying attention to what has been written where. Next index is the leader figuring out what it should send to that server next. So match index is the leader, the leader's idea of where the followers are in terms of their logs, log writes. And next index is accordingly, I guess, determined based on what should be sent next. And then, commit index, every server, what has it committed, and last applied is something I'm not worrying about at all at the moment because it just follows commit and is independent of the rest of the algorithm. And this is the actual log that stores the data, and then current term and voted for are bits that I implemented in part A. I don't have to worry about those anymore. Well, I might if something goes wrong later, but certainly not while I'm sketching. Probably not while I'm implementing either, just maybe at the debug phase. Alright, let me just, because I have a sneaking suspicion the camera's gone out of focus slightly. So I'm just gonna... Yeah, cool. Sneaking suspicion seems to be correct. So I have that, I guess, in me slightly, that I just get slightly vain on camera, and I'm like, oh, I want to sort my hair out and be, a sharp streamer or whatever. But no, I don't worry about it too much, thank God. That would be a bad life. Yeah. Okay, so that's it. That's what next index and match index are. I think I'm trying to get a feel for those. So let's have a look at this now. Next index. Okay, so if last log index is greater than or equal to next index for a follower. What the hell is last log index? That's not even a definition. It's just something I'm supposed to interpret. Um, last yeah, microphone camera. Sorry. Yeah. Last log index is the what? I'm confused. Fan. This is we know who. Okay. Oh, fucking yeah. Okay, sorry. Last log index should be the leaders. Um, last log index. I think that's the index of the leader's last entry, and next index for a follower is what the leader thinks the follower should receive next. I think. Hey, am I experienced in C++? No, not at all. Like absolutely zero experience in C++. Why'd you ask? I'm experienced in Python, JavaScript, and Go, apparently. I'm actually only using Go for this project. Yeah, I haven't even mentioned, because I haven't been doing any coding for like days now, because the theory is so complicated. But yeah, I am doing the project in Go, which is a really cool language for concurrent stuff. JavaScript, I did some bots in it for Pokemon Go, actually. Not bots that play the game, but bots that send notifications whenever rare Pokemon spawned, using a map that was already there, so I didn't make the map myself. And Python I used for maths coursework because I was doing pure maths. Integers in Python are just like, oh my god, one of my favorite things in programming are integers in Python. So as a result, yeah, I've not done anything in C++ yet, but I can learn anything. I mean, hi. I'm getting asked about all these languages. Lua. I mean, I know what Lua is, if that's good enough, but I've not used it before. It's like some random scripting language. It's some random scripting language that um, somebody used for like a probability project in my maths degree, coursework projects. I couldn't tell you. But yeah, guys, thanks for tuning in. I'm going to be around for another, I would say 25 minutes. Then I will quit and go watch House, which is being syndicated over here in the UK on some random Sky channel. I don't know. But I'm just until then, I'm just trying to get through the rest of my sketch of Part B of Raft. Whoa! I clicked the wrong thing. I'm trying to code a voice chat. And I'm stuck. That's an interesting project. Yeah, I've never even thought about doing a voice chat. Um, Chat is, I mean, doing a chat application is not easy, but that's something I might learn in the future, depending on what job I end up with, I guess, because I'm still looking for my first computer science job, actually, my first programming job. Yeah, so yeah, sorry, I can't help with that. There's no way I'd have any idea what to do with a voice chat. I always, even if I don't know a language, I'm like, I can help, maybe. Out of my depth with that kind of thing. But yeah, I wish you luck in finding someone who can help. Voice chat. Voice chat sounds hard. Well, I mean, probably not as hard as this, but still, I can only deal with so many hard things in my life. All right. Yeah. Okay. Okay. So I'm gonna rewrite this immediately because I think I understood it, and this is just not written in a clear way at all. So I'm gonna rewrite it straight off. Basically, what this is leader. So things the leader keeps on top of, things the leader is always doing. One of those things is keep everyone updated. That's a decent enough way of describing what this means. And so we have our if statements. If last log index, my last entry index is greater than or equal to okay, so I'm going to put in a note that this is done for each follower individually. If my last entry index is greater than or equal to next index for that follower, but I think that's implicit because I put per follower at the top, then I do this. Should I just... No, don't do that. It's probably better to use then, but never mind. Colon is a bit Pythonic. Python uses colons for this kind of thing. If my last entry index is greater than or equal to next index for that follower, send append entries RPC with log entries starting at next index. Send append entries with, I'm going to call it payloads because payload is, I'm kind of using that to mean when it comes to append entries. Append entries is the RPC, the message between servers that transmits data that they're trying to synchronize and agree on. So payload is the data that is transmitted in that particular append entries instance. And so what we're saying is payload starting at next index. I think payload should always finish at the last... What the hell is that whining noise? Is that the laptop? Because I know the fan is broken. It's tractoring slightly. No, it's actually the fan that's making the whining noise. That's a bit strange. Okay. Concentrate. Con. C-O-N. Con. If anyone's seen Big Shaq Fire in the Booth with Charlie Sloth, you should watch it. That is British grime humour. It's hilarious. It lasts about 20 minutes. 20 minutes of funniness. Yeah. So I think every append entries that is sent, the payload should start at next index. Yeah. Not even. The payload should start somewhere. I think here it's starting at next index. It explicitly says that. In the you can see where my mouse is in the blueprints. But generally speaking, no matter where it starts, I think it should always finish at the last piece of information the leader has available to it. I think that's sensible. Okay? So yeah, do that. And then it replies, okay? The receiver of append entries replies, and we have already defined how success works here. This is what success is. Receiver has an entry that matched the previous log entry index and term, and previous log entry is according to the follower, the leader, which itself in an append entries message, it sends out its own previous entry index and term. And I was saying earlier, I think I may have defined this incorrectly. I think this probably should be the sender's last entry, the last entry that's in its log, rather than payloads, which depends on things. I'm going to check that in a sec, actually, because I don't want this error to persist if it's still there. I'll also check the chat in a sec. I'm just really distracted now because there's a fucking truck outside, and my window is it's almost a meter open. There's nothing I can do about that. That truck's just going to stay there. I wish I had like rocks I could throw at it, but if I close the window, my room is going to overheat so hard the laptop may even like break. But I just cannot think when there is this much truck noise in here, so wish me luck, wish me luck. I'll just check the camera's still focused. Yeah, camera's okay. And then I'll hit the chat in a sec. Yep. What's up, Star Sailor? Distributed systems. Is it your coursework? Whatever, you wrote it below in info. Fair enough. No, I don't mind. You know, I don't. It's not like I get that much chat usually. I think this is a record. So, thanks. I didn't realize it was that interesting. But yeah, it's distributed systems is something I am self-teaching, and the way I am self-teaching is by going through MIT's coursework. So I have to shout out on Reddit. Somebody first gave me the idea that this was a cool way of learning distributed systems. Just do the practicals. And also Max and Ben, who tried the distributed systems and streamed it on YouTube. I owe them as well, although they seem to find Raft a lot easier than I did. They are computer scientists. I'm not. I'm a mathematician originally. Kind of trying to get a job in software though, so I'm just doing this kind of stuff to pass the time. I'm just going to reopen the window. This twat has gone. Oh God, my collar. Ow. God, am I gonna finish this before house starts? I do not know. It doesn't matter. I'll just pick it up. Oh, by the way, I'm streaming again at 8 p.m. tonight. I've been a bit disorganized lately, starting up to an hour late, but I think honestly, evening sessions aren't that bad, and 8 p.m. should be fine. Are you CS students or fam? I did 3 years of undergraduate maths at Cambridge University in England. I'm in London right now. I live in West London. And that was, a couple of years ago now, actually. I graduated that. And I was a pure mathematician, so everything I learned pretty much was useful to the real world. I just did it because I liked it. I liked the theory. But then I got bored of it because it was too specialized. It was getting even before I started the degree, I kind of predicted, in 2 years the maths is just going to be too specialized. I'm not going to like it anymore. And so third year I was mostly right, but I did find some cool stuff in third year as well. Graph theory, functional analysis, a bit of abstract algebra, and a bit of computation theory. There was actually a Chomsky course as well. Computation theory, automata, formal languages is decent stuff. But yeah, I was definitely not pushing with any further with any maths. And then I just threw myself into practical work, so coding up Discord bots, this bot for Pokemon Go, and now I'm doing something that's kind of a mix between theory and practical. So I'm doing distributed systems, very theoretical shit, but I'm doing it in a very practical way. I'm kind of making a model of a system for myself. I wish I could do an actual real world distributed system and learn it that way, but like there's nothing you can do. If you're a hobbyist, making a distributed system is just, you're not ever going to be working with scale. It's not like your first web project is a lot easier than to do a distributed system from scratch, because not only because distributed systems is hard programming, but also because it's like, what would you do? Can anyone think of like a project for distributed systems? Just a hobbyist project. So this was a good compromise. It was practical. So I'm making models, so it's not the real thing. I'm remaking algorithms that actually exist, but that's still practical enough that I'm kind of enjoying it from a practical mindset. And that's also why I brought in the stream, to just make it a bit more interesting, I guess. God, yeah, the destruction with the fucking truck has really put me off. But now I'll be okay. Yeah, like I said, I'm only going to be around for another 13 odd minutes. Um, so yes, I was actually in the middle of typing this. How the leader keeps everyone up to speed. Oh, and then I backtracked slightly and looked at previous log index and previous log term and decided I've probably got the wrong definition. So I'm just going to fix those. Well, okay, so, you know, I'm just going to excerpt this bit so that everyone can look at it. Look at this definition. Like, this is not clear in any way. I mean, I've really had enough of this paper, seriously. So it says index of, so the log entry, these two, index and term, fine, I know what those are. So every log entry has an index, which is the position it appears in the log, and it also has a term. Term is a reliability thing. That is the term of the server, the server that was leader that received the entry. It assigns to the log the term, its own term. And every server has a term which is basically the election cycle it's on, so that whenever term goes up, everything that's out of date on term just gives up and realizes it got replaced because something broke down. And the elections are done every time the leader is not in contact with a majority of servers. Well, actually, whenever a follower will trigger an election whenever the leader gets out of contact with anyone. But if it stays out of contact, then the leader's not going to notice, neither is the majority of the cluster. They just keep working. But then if it gets back in contact, it's the leader, I think, steps down and there's a re-election, something like that. But basically, term is because that's stuff I did in part A and I'm now in part B. Term is all about how sort of it's all about tracking whether the servers are up to date, and that goes in the log as well. For reasons that are, I mean, okay, if intuitively sure, it makes sense to attach term to log entry so that when we compare log, we know which logs are up to date by proxy of how term is being used. But how it works in practice, I have no idea. So I'm just gonna, try to figure it out just by reading all the bits and pieces. Okay, sorry, digression. Previous entry has an index as a term. That's cool. I know what the index and term are. My point is I don't know what the previous entry is. So look at this. It says here the previous entry is the entry that immediately precedes the new ones. Like, what does this mean? So new entries I want to say is the payload. I want to say the new entries are the entries that the server is sending out. Sorry, the leader that sent the... Because both of these things, by the way, previous index and term, these are arguments that are sent via append entries, the thing that transmits data from the leader to the followers. So the leader is sending this information out, and so it sends out entries, which is the actual data, the payload. And then I think what this means is that the log index, sorry, the previous entry it's talking about is the one that precedes, it's immediately before the payload. So whatever the payload entries are, the one that goes immediately before that. That's not completely clear. I think that's what it is. The alternative is that it is just the... What is the alternative? Hang on. I was thinking, oh, maybe the previous entry is just the leader's previous entry on... In my head, I have it in my head that some of the append entries and requests are just sending out data as soon as it is received by the leader in the first place. In which case, previous log index and term kind of corresponds to what the leader just had before it received this new data it is now sending out. So it is just like a moment ago, what was the leader's final entry? Now that I think about it, that's, it doesn't say anywhere that the leader should be doing that. And if instead we just do all of the append entries RPCs in the sense of oh, the leader is trying to keep everyone up to date, so it's tracking them and is just sending information out all the time via this other system that's detailed here, which I've actually rewritten. It's just about, how the leader keeps everyone updated. So, sorry, my point is just to be clear. There is a distinction between data coming through and triggering a set of updates. Leader receives data, leader sends data on next heartbeat. That is one way of doing it. And another way is, instead of this depending on the flow of data, it's independently always happening that the leader is checking on all the followers, are they up to date on everything? And then if the leader receives something new, it doesn't trigger a send to the followers of that new stuff, but instead it waits for it to naturally get picked up by this cycle of keeping everyone updated. So my thinking was both of these things should be happening. My thinking now is only the keep everyone updated should be happening. This should definitely be happening because it was in the blueprint. But my way of thinking about it as a cycle of data, I think, breaks down here in the sense that the leader doesn't immediately send the data in a cascade of operations. Instead, it just waits for it to be picked up by the keep everyone updated thing. In that sense, I think what I initially wrote about my definitions of the previous entry, these are actually correct. I think this is not mistaken at all. I think it is genuinely different depending on who the leader is sending the information out to. Depending on what the payload is, the entry before that is the one for which we have previous log index and term. And then we take it back to the definition of success. So I'm sorry if this is too fast to follow. I'm just trying to keep it fast enough that I can understand it myself without losing track. We take it to the definition of success, which is to say an append entry's RPC was succeeded if the receiver had an entry that matches prevlog index and prevlog term, the previous entry of the sender, the leader. And the leader is guessing which entry the follower wants next. And so it sends its guess in the form of the previous entry that it thinks, because the thing that the leader sent is the current entries, the payload. That's what it thinks is new to the follower. But what the leader thinks the follower already has is the entry immediately before those. Therefore, it is sending out previous log index and previous log term, which correspond to that previous entry. And the point is that the RPC should be successful if the previous log entry is what the leader thinks it was. So the follower's the follower's last entry, or even any of the follower's entries, matches the previous entry, and therefore the follower is ready to receive the next entries. That's why success is defined the way it is. Okay, I think I understood that finally. So I had a bit of an epiphany there, I guess. This is crazy. Raft is crazy. It's just so chaotic. And that's it. So I think the definition is correct. And okay, just before I check the chat again. This is why we are depending on success. Let me not look at this because this is me trying. I'm going to delete all this stuff when I'm done. This is the stuff I'm currently working on, but I decided it's better to rewrite it from scratch. So this. You can see here, success it's using the word successful where it should be using success equals true, because it is ambiguous, let's face it. I mean, what does successful mean? But yeah, in the situation where success actually happens, what we do is it's fine, it succeeded, and so we decide we update match index for that follower, which is match index. Don't forget, is what the latest piece of information we think the follower has is, just in the right sense, not commit. Commit is something we're not thinking about anymore. and then next index is determined accordingly as that thing plus 1, right? The next thing we want to send. But if it fails, this is the interesting bit. If it fails, what that means is that the entry that the leader thought that the follower had doesn't exist. And so what happens is it decrements the thing that it thinks it should start sending. And that also then implicitly decrements the previous entry. And so because the previous entry is one before the one that was sent last time, it is more likely that the follower has it. And so we keep looping that until the follower finally has the previous entry, in which case the thing that the leader sent, meaning for it to be the next few entries, is accepted, and then we have a success, okay? Okay. Log on, chat. Have you taken algorithms and operating systems courses? OS scheduling and graph search algorithms should be helpful for you. Like you can... Whoa! Sorry. A bee just flew in and landed on my fan. If the bee was smaller, it would have just gone through the fan and died. Like, really, that would have traumatized me. Like, that's already happened with the moth, but it just thankfully left immediately. Sorry. Yeah. OS scheduling and graph search algorithms. Like, you can keep resource allocation graphs, deadlock avoidance measures, etc. Fair enough, thanks. I haven't. Yeah, I've not taken a single computer science course other than a bit of computation theory and like automata and formal languages. I did do graph theory in my maths course, and I did do a little bit of algorithms. Just as a way of preparing for job interviews. So I know about depth first and breadth first search, basically how they work. I've implemented them a few times. I've done my own search algorithms every now and again. So yeah, that's cool. So you're saying, yeah, you can keep allocation graphs for resources in an operating system context, and then deadlock avoidance measures. Fair enough. But I haven't done any OS courses. But it's fair enough that this would be useful to me. That's something I almost certainly it would be. But I don't think it's necessary because well, I don't know. I actually do have, because this course is covered by fairly robust testing that was provided by MIT. The testing has time benchmarks, for example, or I can use Go Time, which is built into Go, which actively times things. And I actually have a bit of information from MIT about how much time things should be taking. And also a few hints about things about deadlock, how it could happen, things to bear in mind. I also have a race condition tester that is provided by Go. So I have a few tools that I could use to watch out for problems. But other than that, yeah, there's nothing that I'm going to be doing myself because I don't have that experience. But I don't think it's strictly necessary because the MIT course is fairly robust and self-contained with its testing. There are a lot of tests. Part B has 7 tests, and I have a pretty solid print debugging as well. I know it's not like actual debugging, but it's good enough. And that's also kind of built into the project because they have their own kind of specialized print function that you can turn on and off. That was already in the codes when I received it. So yeah, you see what I'm saying. That's how I'm going to be doing it. I'm going to be going test first, looking at the tests and what the tests are telling me, rather than going to any like serious measures to implement things like deadlock avoidance. So my strategy is test and benchmark, but also I read through, for example, MIT's guide to locking conventions to avoid, mutex hanging and that kind of stuff. The mutex being the way of locking state variables so that only one thread can access them at a time, that kind of stuff. And so I have the hints and the tests. That's basically it. I don't have the operating systems background. Wish me luck. But yeah, thanks for your comment. It's interesting to have a think about that kind of stuff. With that, by the way, I'm finished for not for today. Sorry, I'm back at 8 p.m. BST. For the avoidance of doubt, because I don't know what time zones people are on, 8 p.m. BST is now it's 2 p.m. So it's in 6 hours time, 6 hours and 3 minutes. 2 to 8 is 6 hours. I had to check that. I don't know why. And what I'm going to be doing is just picking up where I left off and continuing to sketch part B, I guess, which is ongoing. I feel like I've made a solid amount of progress because I've understood how, in concept, I haven't written anything down yet, so thank God I'm continuing today while it's still in my head. But I've kind of understood how success works in the sense of what does success mean in an append entries RPC? How does that correspond to the leader sending the exact information that the follower needs? And the definitions of the state variables, both the things that are the state variables that track what the followers need, the leader's tracking what the follower needs, next index. Excuse me again. As well as the leader sending out its previous entry information so that the followers can check that they actually have it, so that they can take the new data. That's something that I've understood now, I think, pretty solidly. I just had that kind of realization 5 minutes ago. And so I'm going to be writing that out, trying to clear it all up. That's the first thing I'm going to do when I get back on the stream. That basically covers this section. And then there's also going to be some stuff about how the follower actually synchronizes its log, like the dirty of how it's done. So this stuff, these 2 points here. Append the new entries, obviously, but also if existing entries conflict, what gets deleted. Okay, that should all be, now that we've gotten that bit of it, I think that this should be fairly simple. And some unsolved problems we're still thinking about are like when the leader does all this stuff, but that's more implementation detail for later. So I think that'll be it for my second pass of sketching when I've just done those bits and pieces. And then I'll see what needs to be done next. I'll play it by ear, as they say, like figure out what's next. And so that's what's happening at 8 p.m. Whoops. I was going to click the chat. Hey, thanks for the good luck. Pushing through it, Mathmo in the Komsky world, just trying my best. I had some success with MapReduce. MapReduce, that's the first MIT project. It's so much easier. So much easier than this. It's actually crazy. That's why I thought Raft would also be not that hard, but the difficulty stepped up quite a bit, I have to say. But I'm enjoying it, and that's what matters. So yeah, thanks for the good luck. Straight off continuing, 2 p.m. house is about to start. I need to turn this off. And yeah, that's it. I'll be back at 8 p.m. and I'll update everything at the end of the day in terms of the stream stuff, like the VODs, the collection of my progress so far and all that. I'll update that at the very end of the day, I think, because I'm busy today. So I'm just back at 8 p.m. continuing. Okay. Thanks for watching, by the way. It was really nice to have a crowd of people. All of you who took the time, streamers very much enjoy that. I mean, for me, I definitely have no expectations because I'm doing computer science, and it's not that fun to watch, I guess, unless by accident. Sometimes it can be fun if I happen to pick up on something good, but often it can just be kind of a bit of a slog. So thanks for sticking around, and thanks for chatting about that. That's good fun for me, honestly, to just discuss stuff and get my thoughts together on different topics. Back at 8 p.m. Thanks for watching. So in 6 hours from now. See you later. Good luck.